Hello guys, just a little thought on the moment of inertia. Here is a spool of magnet wire, has a certain inner radius, has a measurable outer radius, and then you can actually measure the point about which it spins. If this were a complete full spool, then of course it would be covered out to the end. It might simplify things a little bit, but just a thought. So let's say we had this wire out and we laid it down, and we actually, I don't know if you can see this, there's a wire here between my hand, and I could apply some force along this wire. Let me flip it over so you can see it a little better. So apply some force along this wire, and that would mean that it would result in a torque, and we would have some rotational motion. So I could actually pull this along, and depending on whether or not this force is constant and what magnitude it had, I could actually predict the resulting rotational displacement, the rotational velocity, and the rotational acceleration. I could calculate these as they relate to the initial force and the dimensions of this object. So just wanted to get you thinking about that. Think in terms of applying some force at the outer portion of an object, and it produces that torque by definition of the geometry. And again, everything interrelates to the angular velocity, displacement, and acceleration.